So to write code in ES6, you can't actually ship that code to browsers right now because no browser supports all of ES6. And so you have to do what's called transpiling. And the most common tool out there for transpiling is called Babel, and it's really awesome. And if you're ever just like, oh man, I hate writing ES5, I just want to write some ES6 real quick, then you can be like, const thing equals arrow function whatever, and then it'll like spit out ES5 for you. So if you're like, oh man, I just really want to write some ES6, then there you go. So Babel is what I use and what we use at Alianza to transpile our ES6 code into ES5. And Webpack is, here, let me make this bigger. And this is, by the way, I linked to this repo in the meetup. So if you're curious, you can go check that out. Webpack is the tool that that we use at Alianza to bundle all of our JavaScript together, because currently the way that browsers work is every JavaScript file that you want on your page, you have to put a script tag in there, and the browser goes and gets that script and brings it back. And most browsers can only get 6 at a time. And if your application gets very big, that's a lot of script tags, and your users are sitting there waiting. And so this is the story of today. And so what is common is you'll concatenate your files, you'll uglify your files, so you'll like there are tools that'll take your JavaScript and make it like really small, remove white space, and do all kinds of other cool things to make it as small as possible, so that you have just a single file or a handful of files that you send to the browser, so load times are faster. And so Webpack is the bundling tool that we use. You may have also heard of Browserify, which is also awesome, but I prefer Webpack. And so we'll be looking at a little bit of Webpack. And then Karma is, who here hasn't heard of Karma? Okay, just a handful. So Karma is a test runner. So you write all of your tests, you can use, man, there are so many tools. This is crazy. You can use Mocha or Jasmine or QUnit or like all kinds of other crazy tools to write your tests. But then you need something that will run your tests for you. And generally you'll just like run these in the browser. But we got tired really quick of refreshing our browsers to rerun our tests. And so Karma was built by actually a member of the Angular team to speed up the feedback loop of testing. So yeah, we use Karma to run our tests. And because we are super awesome, we write tests, and that's what awesome people do, is write tests. And so one of the things that's really helpful, especially in a large application, is to determine how much code coverage you have in your tests. What code coverage means is I have a handful of files. We'll just say one file, and it has a handful of lines. There's an if statement here and whatever. Actually, probably better to just like show you really quick. So like if I have a function foo, and I say if, we'll take in bar, if bar, then do something, and else, like, I don't know, baz. Okay, so what code coverage will do is it goes through your code and identifies how many times does this line run, and then how many times does this if statement run and this line run, and then how many times does this else statement run and this line run. And so and this happens like during your test. How many times are these lines run during your tests? And what that tells you is if I have no code coverage over this else statement, and well, that, yeah, this is totally legitimate JavaScript. Like this works. But this would totally throw an error because like, what the junk is this? And so if you don't have code coverage with your tests, then you'll never really discover that until you deploy this out to your customers and things blow up and you're like, I lost money or something. So code coverage helps to ensure that at least your code will run. It may or may not do what you want it to do, but at least you know that it runs. And then writing good tests will help you determine that like your code is actually doing what you want it to do. And then unit tests are good for that, but highly recommend integration tests as well with something that like WebDriver or something like that. But we're just talking about unit tests. Coverage doesn't really apply to integration tests. So yeah, look that up. Does anybody have questions about code coverage and how, like, what that is, how that works? Okay, code coverage is important. Let me quickly, I'll show you like kind of what a code coverage report looks like. So I'm the author of the library Angular Formally. I'm an Angular, a guy who likes Angular, and I really like forums, and sort of. And so this website called codecove.io, it takes my code coverage report and displays it for me, and also I get this nice fancy badge right here that says I have 90% code coverage, which is kind of fun. And so I can go through here and look at my project, and I see, like, these are the number of statements in these file or folders. This is the percent of coverage for those. So here I've got, let's look at this, directives. There's 87% code coverage here. Let's look at formally form. This is a pretty sizable file with 81% code coverage. And then I can look in here. Red lines mean this has been run in your tests. So here's like the number of times that line was run in your tests. And this is actually one line off. I need to figure that out, but this one actually should be up here and these lines should be up. So just take that. But red lines mean, hey, you're not covering this. So if this were to actually happen in production, something weird may happen that you're not expecting. So I'm not testing for the case where the Angular minor version is less than 3, because who cares about that? No, just kidding. I do care because people do still use that. So yeah, and then I've got a whole bunch of lines right here where I'm not testing these cases either. So I need to work on that. PRs welcome. So any questions about coverage and why this is important? Good, great. Now we're going to get into some really confusing stuff, and I'm going to try really hard to explain it well so that it makes sense. So we have this app. I built this an hour ago. And it's really cool because every single time you refresh the page when it's running, which I will make it do right now, every time you refresh, it's going to be like, boom, random user, boom, another random user with random name. So we're using an API called randomuser.me, which is like super awesome and highly recommended for just generating random user data. Yeah, you get all kinds of really handy information. So if we just go to http://api.randomuser.me, then every time we hit this endpoint, it's going to give us a new user and information about that user that we can use in our app. So this is a really cool app. I am so excited about this, but I really don't want to break anything. And so I want to make sure that I cover all the code paths to make sure that I'm not going to blow anything up. So right now, what I've got is text that's way too small for you guys to read. So we're going to fix that real quick. Fonts. Going to do, there we go. How's that? Okay, so right now I do have some tests, and everything is set up using Webpack with Babel, and Joe Eames told me that he talked about Webpack already to this group, so you guys are all like total professionals with Webpack, I'm sure. If you're not, that's okay, because I actually am an Egghead.io author, and you can go learn about Webpack from my lessons on Egghead.io. Who here has heard of Egghead.io, by the way? Okay, great. If you haven't, go look it up, egghead.io, and I'm on there, and you can learn Webpack, and it's great. Okay, so yeah, I should probably talk a little bit about my Webpack setup right from the get-go, because we are going to be working with it. So I got tired of setting up Webpack over and over and over again, so I created a library called KCD Common Tools. And this, don't read too much into it, but basically All it does is it has a couple of common things that I use in all of my libraries and projects and stuff. One of those things is a Webpack config, and this is scary and big, but it's super amazingly powerful, and it is running like 4 of my libraries right now. It's super, super awesome. So the thing that we're going to concern ourselves with is the loaders. So, and we're not going to talk about this right now, but I'll explain what the loaders do, and it will apply later. So basically, what a loader does is it says, hey Webpack, anytime you encounter a file that passes this regex test with its file name, so in this case anything that ends in a .js, I want you to pass it through these loaders. And I'm specifying ng-annotate because lots of my stuff is in Angular, and Babel and ESLint, but it runs in reverse order. So it's going to, ESLint is a linting tool which basically checks for common errors and mistakes in your programs. So yeah, that's what that is. And Babel is what we're using to transpile our ES6 code. So we pipe our ES6 code into ESLint, then it goes into Babel and it transpiles into ES5, and then it goes into ng-annotate, which is an Angular thing, and you don't really need to care about that right now because Angular is great, but we don't need to talk about it. So that's the idea. What we need to do though is we are the way that code coverage works is, if you remember right here with this guy, we need to be able to somehow say, hey, I want you to tell me when this line is run and when this line is run and so on. And so the way that that's actually accomplished is we don't have to do this. There are tools for this. But basically you have like, I don't know exactly how it works, but it's like var counter is an object, and we'll say counter 0 plus plus, and then we'll say counter 1 plus plus, and we'll make this an array just because things, and counter 2 plus plus. And then when all of this runs, we can say, okay, so how many times was counter at index 2 run? And you can find that out from that information. So that's kind of how the tool that we're going to use works, is it just sticks in a ton of stuff into your code. Like, maybe I'll show you. It's crazy. And it like increments every time you hit that line of code to know what that line of code is doing. And it gets really crazy when you do stuff like, I don't know, var or let's say var thing equals bar question mark whatever or otherwise other thing, and so then it's got to like stick its plus plus in weird places and stuff. But it's cool and it works and it's awesome. Again, okay. So the tool that we're going to use is, if we go JavaScript Coverage, the result is you got blanket.js, which is cool, but we don't care about blanket.js here. We care about Istanbul, and Istanbul is super, super awesome, and it works really, really well. And it has high test coverage, which is fun. So basically, Istanbul is going to stick all this stuff in our code for us, and poof, we know our code coverage. But the problem is that Istanbul doesn't understand ES6, so it doesn't know how to say, like, if I have arrow function here, it doesn't know what to do with this. And so what we need is to figure out some way to say, hey, Istanbul, I'm actually using ES6, so you need to like parse me correctly. And so if we just go JavaScript ES6 coverage, then we'll look here. Oh, Isparta, that looks cool. It's a code coverage tool for ES6, specifically Babel or 6 to 5, which is what Babel used to be called. And so we look down here, and yeah, this is cool. It actually uses, or let's see, I think it does use Istanbul. I think it does, Istanbul, yeah. So it uses Istanbul, but it kind of teaches Istanbul, hey, this is ES6, this is how you, or where you put your stuff. But Isparta by itself isn't going to help us because we're using Webpack, and so we need to say, hey Webpack, I want you to run all my JavaScript through Isparta, which will run my JavaScript through Istanbul, so I can get coverage. Have I lost anybody yet? I have? Starting to. Dang it. Okay, so I'll take a quick step back. So remember with Webpack, we have these, well, let me take a step further back or forward, however you want to say it, and I'll show you what the code of the app looks like really quick. So if you're familiar with like node programming, you have what's called CommonJS, which is how you, it's a module syntax. So it's like we say var x equals require my thing. Anybody seen this before, like this concept? Okay, so this is CommonJS. This is a module system because globals were not a good idea. And so Node makes this really easy because they can manage this syntax or this module. What I'm at loss for words, but like this module structure for you. And then ES6 comes around and says, "Hey, we're finally going to support modules in JavaScript." And so the now we have import thing from some file. And so the equivalent to this line right here is var get random user. Actually, technically it's const equals require get random user. So these two lines are sort of kind of equivalent for all intents and purposes because we're building with Webpack. And so like shield your eyes from this because materialize is doing things kind of wonky. So like, yeah, I shouldn't have even brought in materialize because like, heck, how hard is this? So anyway, yeah, so we have this module syntax, and so now all of our files can be spread across all over the place in our file system. Okay, they can be anywhere, and so and each one represents a module, like a piece of behavior that is hopefully modular and reusable and good and happy. So here we have this getRandomUser file or function that we're calling down here, returns a promise, and that's where we get this then magic from. And then we have this getUserCard, which will evidently return some string that is HTML that we'll set in the card, which is this card right here. So we have these two modules, and when we do this import to get the code for this module, what Webpack is going to do is when it like generates our final file, which actually I should show you. It looks like, well, that's a bad example. Let me let's see, Webpack. Oh, criminy. Hold on 1 second. Okay, so if I build my project, the output does not look like, where is it? There it is. Okay, so the output is going to be huge because I've got Lodash and a bunch of other crazy things in here. But well, now it's all kinds of confusing. Sorry, forget about all that. That was not useful. Okay, but basically, we have a bunch of files. Webpack brings them all together into a single file, and it manages when I say, hey, I need this module, or I need to I have this dependency or whatever. So when Webpack is building this file, we can tell it to transform that data or that file into something that, like, whatever we want it to. And in our case, we want to transform it from ES6 to ES5 so it can be run in the browser, in today's browsers. Okay, so that is what this concept of loaders is all about. Is for every file that you find when you're resolving all these dependencies, like this is requiring a JavaScript file, I want you to run it through, forget ESLint, I want you to run it through Babel so that you can take it from ES6 down to ES5. Does that make sense? Okay, great. So in addition to that, when we're running in test mode, we need to add these wonky counter things that Istanbul will do for us. And so, well, sort of after it's been transpiled to ES6, we're going to add these counters. So that actually it's kind of before. Sorry. But so at some point we need to add these counters to the file. So that's another loader. That's another transform to our code that happens when we're testing, when we're counting our coverage. So does that part make sense? It's just another loader. Okay. It will happen. It will happen before, I think. We will see. Yeah, if I get to it. Okay, so we'll say, so now we need to have a Webpack loader for this awesome tool called Isparta, which allows us to have Istanbul with ES6. Okay, great. See, and this is why I wanted to give this talk, because it took me like 3 days to get this working. But now it works, and it's awesome. So we're going to do JavaScript, Webpack, Code, Coverage, ES6. Let's see if this will give us anything useful. Hey, look, Isparta loader. That looks promising. So all of Webpack things or all of these things are called loaders, and so easier search would have been Isparta loader. Boom, there it is. Okay, so this allows us to take or to add a loader to our Webpack configuration that will add the Isparta stuff to our JavaScript, which will add the Istanbul code coverage counting to our ES6. Okay, we're all following along, holding hands through this really confusing stuff. Okay, so it gives us an explanation of all of this really handy, useful stuff, and so you can spend a couple hours figuring out how to do that, because that's what I did. But we're actually going to try and implement this. So pray for me, because yeah, not a lot of time. Okay. So does anybody have any questions before I actually get started implementing code coverage in what we have already in our app? Okay, great. So let's take a look at our tests as they stand today. So not very useful tests. So we have this get random user test, and basically that just gets our get random user function, and so that function is here, and we want to test this function to make sure that it gets this URL, so API random user me, and then does stuff with the user. We're actually not going to test this one because it's a little bit more complicated. We will test the other one, which actually, incidentally, looks exactly the same. So all it does is it expects false to be false, and we're using chai with the expect assertions, and we're using Mocha, and like there are so many tools in JavaScript land. I am so sorry. But that's one of the reasons I created KCD Common Tools, because I was so tired of setting this up every single time. But man, I love JavaScript. Okay, so what we want to do is like we could write the test and like get good coverage, but I'm not going to actually write the test right now. I don't want I want to show you guys what your coverage would look like if you didn't have any tests at all, and then what it looks like when you actually start writing tests and improving your coverage. Oh, okay, so here's where things start to get confusing. Okay, so what we need to do is, like I said, we need to add the Isparta loader to our Webpack configuration, but we only want it to apply to our own code, not our test code. Because if we were to measure our coverage of both our tests and our actual application, our tests would have pretty much 100% code coverage, and it would inflate our overall number, right? And we don't care about our test code coverage. We care about our code's code coverage, right? Okay. So what we're going to do, that concept that I just explained is part of what makes some of this a little bit complicated. So I think probably, yeah, this is going to be a little confusing, but just bear with me. So here we have a Karma configuration file. Who is familiar with what this file is and what it does? Oh, okay. So Karma, the test runner, needs to know how to run our tests. So we need to configure it. And all that Karma really cares about is that you have a file called karma conf, or you can call it whatever you want, and you just have to tell it which file you're using. And it needs to have a module exports that exports a function. So this is common JS syntax because we're running this in Node. And this function accepts a configuration, and on that configuration you say set, and you pass in your configuration object. So let's look at what this configuration object looks like. There are a bunch of things here that I'm not going to explain because they're not totally pertinent to what we're doing, and you can learn them from tons of other resources. But what is pertinent, like I said, we're using Chai and Mocha. Our files, yeah, Webpack stuff. Let me see if there's an easy way to explain this. So basically, we need to tell Karma which files need to be loaded into the browser for the testing. So normally this would be like all of your test files and all of your all the files, files that you're actually testing. But because we're running everything through Webpack, it all actually ends up being concatenated into a single file anyway. And so we're just, this entry is being assigned to a variable which actually resolves to this index.test file, which is importing our tests, which will actually, each one of these will get our actual units that we're testing. And so that's how everything all comes back together. It's all magical and happy and good. So one day, in the far distant future, I'm afraid, we will not have to worry about all this concatenating together mess, and it'll just work and it'll be nice. But welcome to JavaScript. So we basically have just one file, and then we tell Karma that we have a preprocessor that we want to run across all of our files that have a .test.js, which incidentally for us is just this index.test.js. And the preprocessor is Webpack, so it will say, oh, here's this index.test.js. I'm going to resolve all of the modules and concatenate it all into one big file, and then I'll give it to you, Karma. So that's kind of what that's doing. Then we have our reporters, and this is basically so actually here, if I run npm run test, and basically all this is doing is, whoops, package JSON. We have these scripts in our package JSON, and if you don't know what package JSON is, that's okay. Learn it because it's great. But we have a script in here that it has test, and all this does is it sets an environment variable to test so that our Karma config and our Webpack config can can modify themselves according to the fact that our environment is test. And then we say Karma start, so that's the command, and that's Karma, like that's a Karma command. Yeah. So we start our Karma, and it'll open up the browser and do all the tests for us and all that magic. So if I run npm, and actually we can just do npm test, then it like takes my Karma configuration, does a bunch of stuff, and then it runs my tests. And it looks, yeah, and it's great. And we're running in Firefox. So fancy stuff. We have 2 successes, and this, what you're seeing right here, is this is the progress reporter. So it's reporting to us the progress of our tests. So if I were to go in here and say get user card.test and say expect false to be true, then that would fail, and the progress reporter will tell us that. And for some reason it's running twice, and I don't know why. Try again. So, yep, still running twice. No worries. A test for what? To make sure it doesn't run twice. It did not run twice. No, dang it. No. Okay, so that is reporters, and I shouldn't have had this here. Pretend that wasn't there, but I'm going to leave it there anyway. But this is pushing the coverage reporter, which we'll use in a moment, when we're in coverage mode, which is when the coverage environment variable is set to true. Don't worry about that right now. Okay, so then we specify our Webpack configuration so that our Webpack preprocessor knows how to deal with the index.test file. So it's using the same, almost the same configuration, but this is what we're going to be modifying so that we can add our loaders and get our coverage. Then we specify a couple other handy options that aren't pertinent and some of our plugins. Yeah, so all that we really care about right now is we have this Webpack config that we need to modify, and we invoke this function get test Webpack config, which we're going to modify when we're in coverage mode. Okay, everybody with me there? Okay, great. You're all in this room. Yeah, I wish that I was smarter and could explain things more clearly. Okay, but this is where our actual modifications to our Webpack configuration will happen. So, to know how to modify these, this configuration, we need to know what we're actually going to modify. And so here we're requiring the KCD Common Tools shared Webpack config. So this is the object or the configuration object that we're going to be modifying to make it work with Istanbul and Isparta and Isparta loader and yeah, all that great stuff. So let's take a look at it. The only thing that we really care about is modifying the loaders. So we have a loader in here for HTML. Don't worry about that. But one of my favorite parts about Webpack is you can require HTML and it like just comes to you as a string and it's magical and awesome. So if you're an Angular developer and you're writing template URL everywhere and then you move your files and you hate your life, yeah, you don't need to worry about that with Webpack and the raw loader. Ha, it's awesome. But don't hate your life because your life is great. So our next loader is for our JavaScript stuff, and this is the one that we're going to modify so that we can add all of those counters in our code to get our code coverage. Okay? So far, so good? Okay, great. At least the people I hadn't already lost are still not lost, right? So hopefully. Okay, so we're going to get a reference to this item in our loaders array and modify it, and then we're actually going to add a couple more loaders. I hope this goes over well. Actually, you know what? With the fact that I'm supposed to be done like right now, right? Yeah. So this is why I did this. We're just going to git checkout practice 1, and boom, it's all done. Amazing. So, tip of the day. You don't actually, like, if you decide that, hey, KCD Common Tools actually looks pretty cool, you won't actually even have to write this file because I've already done it. So, but if you're interested in how it works, this is how. So when we're in coverage mode, specifically when the environment variable coverage is set to true, and that is the case for when we run test, we say, hey, coverage is true, and the node environment is test. Okay, so when we're in coverage mode, then we are going to take this test Webpack config and we are going to modify the loaders. We assign that loaders there. We get the JS loader, and we do this crazy regex to exclude basically our test files and mock files too, because we don't have any of those, but like you should because mock files are useful. Yeah, don't worry about that. So we're going to exclude both our node modules because we don't want to pre-process any of our dependencies because they should all be good and set to go. But we're also going to exclude our test files because we don't want to report coverage on those. And then we're going to add another loader that will run anything that is not a test or a mock file through Isparta to add our coverage stuff. And then we're going to add another loader for our test stuff to run it through Babel and ES6. So we have linting on our test code, and we can write our test code through Babel, so we can write it in ES6. Magical, right? Okay, so I really hope that almost made sense to some of you. Okay, so we're going to go ahead and run npm. Here, let me make this a tad bigger. Npm test. And npm is Node Package Manager, and it when you do a script like this, it will reference your package.json scripts. And start and test are special for build, and anything else that you put in here you have to do run, and then whatever the name of the thing is. But start and test are special. So we're going to test. And oh yeah, sorry, 1 second. So one of the things that I did in that magical boom, everything's working, is I installed a couple of things like the like Isparta and Isparta loader and and Karma coverage. So there are a couple of dependencies that I wish I could have shown you me installing, but I didn't. So we're going to install those really quick so that everything works. Because hey, I can't code the world, but I can use code other people wrote. So now we'll run npm test, and we're recording coverage. This is great. We get some ESLint errors because I'm not sure what happened, to be totally honest. But now we get our first example of code coverage summary. So this is kind of neat. I can see that 78% of my statements are covered during my testing, and 100% of my branches are covered during my testing, and 50% of my functions, and 55% of my lines. This is awesome. But it's not, because I could be so much better, because I'm actually not testing anything at all. And in a bigger application, like when I implemented this in our app, it was like 20% or less, and that was really sad. We are now at 50. Woo! So going up. And that's one of the benefits of code coverage, is that once you know, then you're like, oh, I should actually like start writing tests, and you feel accountable, and it's good. So code coverage is good. Okay, so and one other thing that was added magically was this configuration. So we say for our coverage reporter, we're going to add a couple of reporters, and the one that you're seeing right here, this reporter, is the text summary reporter. But we also have another reporter called lcov, and like don't worry as much about this. It's like there's this whole standard around test coverage and stuff. But we're going to output our report to a directory called coverage, and that is magically right here. And so we have this lcov report, and there's an index.html. Let's take a look at that. So if I open this in the browser, then boom, I have my code coverage report. So I can look inside of here and see my source, and so like I see all my files, where they're located. The user card has 100% code coverage, and it's not supposed to, oh wait, yeah, it is supposed to. The random user doesn't have like any code coverage whatsoever, and so like that's something that I need to cover. But let's go, sorry, part of the other, like another part of the magical thing that happened when I checked out that branch was it actually changed our tests. So let's just comment out this line really quick, or we'll set it to an empty string and comment out this line, because by me invoking this function right here, I'm actually covering that function because I'm invoking it and that line runs. Okay, so if I save this, now I'm no longer calling that function in my test, and so like that stinks and life is awful because now I'm not covered. How sad is that? Really sad. So basically all that you need to do to increase your code coverage is make sure that every line is run in a test. And so if I call this function, now this return statement will run, and my code coverage is better. Hooray! So let's just really quickly make a contrived example to make our code coverage a little bit different. So I say if user.name equals Bob, then I'll return something else, and for all other cases we'll return this awesome HTML that's in my JavaScript. Thank you, React. This isn't React, but heavily influenced? I don't know. Anyway, so in this case I'll return, hey Bob, and that's going to be just like whatever. So now I save that. My tests are automatically rerunning every time I save, and if I go back to the browser, now I get this output. So yes, this did run with my test because the user's name was not Bob, and so this else statement ran, but this if statement didn't run, and so Istanbul is saying, hey bro, you didn't actually test anything here. So now if I want to increase my code coverage and my ability to sleep at night, then I'm going to say it should return hey Bob if I pass in a user with the name of Bob. And so then this is kind of like all messed up the way I have this all set up. So here, let's do set HTML. we'll move this down here, and then we'll invoke this right here. Oops. And we'll do the same thing here, but before we do that, we'll say user.name equals Bob. And then we'll expect the text. Oh, whoops. Here, we'll go back. Oh, actually, yeah, we'll expect the node.inner HTML to equal hey Bob, Bobo. Okay, does everybody see how this test is working? Okay, so I'm setting the user's name to Bob, and then I say, hey, set this HTML, in which case I call getUserCard with the user whose name I just set to Bob. And so that will pass through this if statement and say, oh, the user's name is Bob, I will return hey Bob, and that gets assigned to inner HTML, and then I will expect that the inner HTML is equal to hey Bob. So this test should pass, and when it runs, then my code coverage is complete, 100% in this file. So this is great. I often will put live reload on this page so that I can just be watching it as I'm like writing out my test and like, okay, now I need to make sure that I cover this, and boom, before long I have at least like 90% code coverage in a file, and that's great. It makes you feel better about deploying code. So yeah, anybody have any questions? Yes?
Earlier you showed us a different code coverage.
Oh, yeah. So this, good question. So this tool is just generated by Istanbul, and it's just like static files. So you can actually even just look at them in this coverage. You see the LCov report, and then you see source, and then the actual files that you're seeing in your browser. So there are several tools, and I evaluated many to determine what tool I want to use for coverage reporting online, and they provide a lot of really handy like features that are really helpful. So for example, if somebody submits a pull request to your open source GitHub repo, then these tools will run the or take the code coverage report on that pull request and stick it into the comments on that pull request. So you can see, oh, this person is adding code to my project, but they didn't write any tests, so my coverage is going to go down if I merge it. And like tons of stuff like that. And then you can like go and look online, and everybody can look online and see, oh, this guy doesn't know how to write tests to cover his code, or like, wow, that's really impressive. I feel much more confident using that library. So
this is the one you prefer to suggest using.
Yeah, CodeCove is great. There's also Code Climate, which is good, and Coveralls is good, and I know now I'm forgetting one that I evaluated, and I feel bad because they're also good, whoever they are. Oh, Codacy is also good. So for local stuff though, like I really like using the what is this thing called? The LCov reporter for code coverage, because then I can just see this here. I have live reload running right here, and I have this live reload extension on in Chrome that will basically reload my browser automatically anytime that coverage file changes. And so I can just be typing, I hit save, test runs, this refreshes, I'm like, okay, yeah, I covered that. So that's my workflow. Good question. Any other questions? Anybody not convinced that coverage is worth it? You wouldn't admit to that. Coverage is totally worth it, and tracking coverage is worth it. I would caution against striving for 100% code coverage, because like code coverage is not the end-all be-all solution. Like if I have 100% code coverage, I will never ship a bug. That is totally not true. But good code coverage ensures that your users aren't going to be running code that that you didn't. And that also like has another implication in like global state and stuff, like you got to be careful of. So make your functions as stateless as possible and like blah blah blah. But anyway, any other questions? Feel free to ping me on Twitter or something if you have questions. Thank you.